Hello friends, this is Nilima. Welcome to NJ Electronics. Today we are going to learn how to perform practical of logic gates. Here we have trainer kit of logic gate. You can see here we have AND gate, OR gate, NOT gate, NAND gate, NOR gate. This here is on and off switch. Logic 0 and logic 1 outputs are provided. Logic 0 is when power supply is 0 and logic 1 is when power supply is plus VCC. And one output terminal is given. On that output, LED is attached which will glow when output is high and it will be off when output will low. Now let's see study of each gate, its connection one by one with the help of these connecting cords. Here we are using these two cords for inputs A and B and this third cord for the output Y. Now let's start with logic gate AND. In AND gate, when both inputs are 0, that means A is connected to 0, logic 0 and B is also connected to logic 0, output will be 0. So, output LED remains off. The next condition is when input A is 0 and input B is 1. In this condition, output Y remains 0. You can see the truth table of AND gate. Now, third condition comes when A is 1 and B is 0. Now, let's connect A to the logic 1 and B to the logic 0. Now, output Y is again 0. The last condition is when both inputs are 1 and connect Y to the output terminal to get output 1. So, from this truth table we can observe when all inputs are high, output remain high. If any of the input is low, then output is low. This is the truth table of logic AND gate. Now let's see the OR gate. The second gate is logic OR. Again we have two inputs A and B. Let's connect output Y to the output terminal to get proper output. Now A is connected to logic 0, B is also connected to logic 0. Then the output Y will be 0. Second condition is when A is 0 and B is 1. In this condition, output is 1. When A is 1 and B is 0, then output will be 1. When both inputs are high, that is logic 1, output will be 1. Thus, from the study of truth table, we can say that in OR gate, when all inputs are low, output will be low. If any of the input is high, then output will be high. Now let's see the third gate, that is a NOT gate. It is also known as negation, which inverts the input. Here we can see the third gate is NOT gate, which has single input and single output. Whenever we apply low input, that is logic 0, you will get high output. Here for input 0, we get output 1. Now let's try input 1, then you will get output 0. It complements the input. So, this is the truth table of NOT gate. Now let's see the working condition of NAND gate. NAND gate is nothing but AND gate plus NOT gate. It is opposite to AND gate. So the fourth one is NAND gate. Let's apply both inputs to the logic 0. Then at the output you will get logic 1. When A is connected to logic 0 and B is connected to logic 1, then also output will be high. Now logic 1 is applied to input A and logic 0 to input B. In this condition, the output of NAND gate is 1. When both inputs are high, output will be low. So, from this we can say that whenever all inputs are high, output of NAND gate will be low. In NOR gate, when OR and NOT combine together, we will get NOR. That means OR is opposite to NOR. When both inputs given to the NOR gate is low, output will be high. When A is 0 and B is 1, in that condition you will get output 0. When A is high and B is low, in that condition also you will get output 0. When both inputs are high, then you will get output 0. So, from this condition, we can say that the output of NOR gate is high only when all inputs are 0. Otherwise, it remains low. Friends, similarly, you can connect XOR gate and XNOR gate and you can study their truth tables. I hope you will understand how to perform the practical of logic gates. If you like this video, please share with your friends, subscribe my YouTube channel and don't forget to press bell icon. Thank you.